Welcome back to another deep dive just for you. Today, we're really getting into the weeds, looking at the architecture behind the AI systems being built right now. This is all part of our research for the minds we're building, which is going to be episode 3 of the Before AGI podcast. Now, everyone knows about large language models, right? Those super fluent chatbots, but things are moving fast. So our mission today, let's cut through the hype. What's the real architectural difference? The thing that separates a, let's say, reactive chatbot from one of these proactive autonomous AI agents? We want to pull out the key ideas about how memory, tools, and goals are shaping AI and, figure out if this is really leading towards AGI or if it's just much smarter automation. Okay, let's unpack this.
Right. I think the first thing for you, the listener, to really grasp is the basic mode of operation. It's a strategic difference, not just technical tweaks. We're shifting from something that just responds to what you type to something that can actually sort of take initiative towards a goal you set.
Okay, let's start with the familiar territory then. The standard generative chatbots we all interact with. They're amazing, sure, but they always feel a bit stuck in the moment, don't they? What makes them fundamentally reactive?
Well, they are purely reactive systems. That's the core. Their whole function is to generate text based only on the immediate prompts you give them. They use all that training data, mountains of it, basically to predict the next word, the next sentence. It's pattern matching on a massive scale.
Like that brilliant librarian analogy you used, stuck in their library, waiting for a request.
Exactly. They can find and generate amazing stuff, but they don't plan, they don't decide what to do next. They wait for your instructions.
And like IBM points out, even though they seem really versatile, they're still technically narrow AI, designed for one thing, text generation.
Precisely. Now, autonomous AI agents, they're quite different under the hood. They use an LLM as the core, the brain, if you will. But crucially, they integrate other components, architectural pieces, that give them this autonomy.
So it's not just about being faster or bigger.
Yeah.
It's like we've given them, a to-do list and the ability to check things off, a bit like a project manager.
That's actually a great analogy, a project manager. You give it a high-level goal, right? Something like research the AI market trends for this year and draft a presentation. The agent then has to figure out the steps itself. Okay, first, search the web. Second, pull out key findings. Third, outline the presentation. Fourth, actually write the draft. And it does this over multiple steps, potentially over time, without needing you to constantly nudge it along. It's driven by that initial goal.
And we're seeing these already out there, right? Things like AutoGPT, Baby AGI. These open source projects kind of show the potential.
Yes, those were early examples showing this proactive, multi-step approach.
So this distinction is key for understanding where things are heading. Reactive systems for maybe quick info lookups, but these proactive agents for tackling complex jobs. Okay, this is where it gets really fascinating for me. This proactivity, this project manager capability, it's not just magic. It seems to rely on, 3 main pillars that sort of mimic how we think? Let's dig into pillar 1, memory and state management.
Yeah, and this is probably the biggest practical challenge right now. The basic chatbot's memory is, well, it's fragile. It's limited to the context window. Think of that context window as just a temporary scratch pad for the current conversation.
Right, and when the chat ends.
It's gone, wiped clean. That's what leads to what researchers call catastrophic forgetting. The model doesn't actually learn or update its core knowledge from your chat. It just uses the scratch pad.
Which is why it's so frustrating. You tell us something important,
Yeah.
and 5 minutes later you have to say it again. It's basically stateless.
Exactly. Agents trying to get around this. The architecture often includes external memory, like a vector database, to store information long-term across sessions.
So they're essentially keeping notes.
Pretty much. But even with this external memory, it's still a major hurdle. Our sources mention studies showing even top models, when used in agents, can fail basic recall tasks surprisingly often, like 1 out of 8 times. They're keeping records, but they aren't truly internalizing information or experiences like a human would. It's still fundamentally stateless at the LLM core.
Okay, so the research is focusing on making those notes smarter. Like Amazon's agent core trying to figure out what's important, like remembering I'm vegetarian versus just random chatter.
Exactly. Filtering the signal from the noise in that external memory is crucial, learning to distinguish meaningful insights.
Okay, but if memory is tricky, how do these agents deal with the fact that the world changes constantly? The LLM's knowledge is frozen in time, right?
That leads us perfectly into the second pillar, tool integration, sometimes called extended cognition.
Right, giving the agent tools. This is how it connects its reasoning to the real live world.
Precisely. Tools bridge that gap. They tackle two big LLM weaknesses. That static knowledge cutoff date you mentioned, and also the fact that LLMs are surprisingly bad at exact calculations, like math.
What kind of tools are we talking about?
Things like web search APIs, calculators or code interpreters for math, maybe connecting to databases, or even other software APIs. Basically anything that lets the agent pull in live information or perform precise actions.
And this isn't just a theoretical nice to have. Giving them tools actually makes a big difference in performance.
Oh, a huge difference. We saw data showing tool-equipped agents boosted performance by, I think it was a median of 53 percentage points in complex areas like clinical healthcare tasks. That's massive.
Wow, 53%.
Yeah. And it's because tools allow this Luke, the React framework. The agent reasons about what it needs, acts by calling a tool, and then observes the result from the tool to inform its next step of reasoning.
Reason, act, observe, that loop. That sounds like the engine driving the proactivity.
It really is.
Okay, so we have memory, even if imperfect, and tools. What's the final piece? Pillar 3, goals and planning.
This is really what defines an agent. It's the ability to take an explicit goal that you, the human, give it, and then pursue that goal. Like we discussed with the project manager idea, it breaks the goal down, figures out the steps using reasoning and maybe tools, executes a step, sees what happened, and then loops back until the main objective is met. It's about operational execution.
But hang on, if an agent can take a complex goal, break it down into 10 steps, use tools, manage its memory, and get the job done, isn't that pretty close to real autonomy? Especially when we start thinking about AGI. Where's the line?
That's the million-dollar question, isn't it? And it highlights the critical limitation. Yes, they have operational autonomy. They can act towards the goal. But, and this is crucial, the goal itself is always given to them by a human. They operate under explicit, human-defined rules and objectives. They lack what's called goal autonomy. They can't generate their own objectives. They don't have internal motivations or decide for themselves what problems are actually worth solving. They are incredibly sophisticated goal achievers, not goal setters.
Okay, that's a really important distinction. Goal achievers, not goal setters. So we built these systems that are amazing simulators. They can manage memory, use tools, plan, follow goals, which naturally brings us to the big question. Are we actually building minds here, or just incredibly convincing illusions of minds?
Well, if you look at the consensus from sources like IBM, Gartner, the current thinking leans heavily towards advanced automation, specifically narrow automation, not AGI. IBM is quite clear. All AI today is still artificial narrow intelligence. It's specialized. Gartner predicts that by 2026, these agents will be better, yes, but as task-specific autonomous systems, still tools, essentially.
And there's a fundamental vulnerability shared by both chatbots and these agents, right? This idea that they simulate understanding.
Exactly. At their core, they're still pattern predictors, and that mechanism makes them prone to making things up confabulation or hallucination. They generate stuff that sounds perfectly plausible, grammatically correct, but is just wrong, factually incorrect.
It sounds a lot like that philosophical argument, the Chinese room thought experiment.
It connects directly to Searle's Chinese room, yes. Just because you can manipulate symbols according to rules perfectly doesn't mean you understand the meaning behind those symbols. The LLM is like the person in the room shuffling Chinese characters. It looks like understanding from the outside, but there's no actual comprehension happening inside.
And we humans are easily fooled by this performance.
We really are. There's this psychological effect called semantic pareidolia. We tend to see meaning and intention, even mind-like qualities, in things that are just complex patterns, especially when it involves fluent language.
So we project understanding onto the machine because its language is so good.
Pretty much. We're wired to interpret fluent communication as a sign of intelligence.
Okay, that really grounds things. So if scaling up current architectures isn't the direct path to AGI, what are the really deep unsolved problems, the bottlenecks holding us back?
There are several fundamental challenges that need breakthroughs, not just more data or bigger models. We can probably boil down to 4 key areas. First, continual learning. Models today are terrible at learning over time. They suffer from that catastrophic forgetting we talked about. They can't easily integrate new knowledge without basically being retrained from scratch or near scratch.
Right, they don't learn from experience in a lasting way. Second
is goal autonomy, which we just discussed. They have no internal drive, no ability to set their own objectives based on their own values or understanding of the world. They only do what we tell them.
Okay.
Third is reasoning reliability. Despite seeming logical, they still make basic reasoning errors pretty often.
Yeah.
They work off correlations in data, not deep causal understanding or robust common sense. Think statistics versus physics. They're great at stats, bad at intuitive physics.
And the last one, which seems critical for real-world use.
Yes. Fourth is explainability. Why did the agent make that decision? Why did it call that tool instead of another? It's mostly a black box. That lack of transparency makes it really hard to trust them or audit their actions, especially in high-stakes situations like finance or healthcare.
So continual learning, goal autonomy, reasoning reliability, and explainability. Those are the big mountains to climb.
Those are definitely some of the major ones, yeah. Deep architectural challenges.
Okay, so wrapping this up for someone thinking about using these technologies now, what's a practical advice? Chatbot or agent?
It really comes down to a strategic choice based on risk and reward. Chatbots. They're mature technology now, relatively low risk, great for those reactive tasks, answering questions, retrieving info, basic customer interactions. Agents. They offer a much higher reward, tackling complex, multi-step tasks proactively. But they also come with higher risk right now. Their limitations in memory, reasoning reliability, and that lack of true goal understanding mean you absolutely need careful human oversight. They're powerful tools, but still brittle in some ways.
So the big picture seems to be, we've gotten incredibly good at building systems that simulate intelligence. They can plan, use tools, follow goals in really impressive ways. But we have to remember that distinction, that architectural difference. We're mastering the art of building incredibly sophisticated tools that can augment us, automate tasks. But creating true general intelligence, something that learns continuously, sets its own goals, truly understands, that fundamental architectural challenge, well, that's still ahead of us. Thank you so much for diving deep with us today into the minds we're building. If you found this valuable and you want to stay updated on AI progress, please do subscribe to the Before AGI podcast. And hey, for more hands-on tutorials, practical insights into building and using these kinds of complex systems, feel free to check out the YouTube channel, Ochieng AI. That's Ochieng. We really appreciate you diving deep with us today.